All right, so today is review day. Just work through some of the problems like the ones on the practice test. So just a reminder, I do have a practice test in Hogs. Okay? You can take it as many times as you want to, but you don't have to take it any if you don't want to. Okay? It's just a study tool. But all we're going through today are just versions of the problems that are on the practice test. Okay? So it'll change the numbers around and things every time you go to one. So your numbers are probably a little bit different than what I've got. Okay. All right, anybody have just any general questions before we start looking at the practice test? Same process as the last test. I'll have a formula sheet for you. It has all the formulas you need on there. Be taking it in here, and it'll just be a plain old paper test, okay, just like test 1 was. Can't think of anything? Okay, we'll start looking at the practice test then. All right, so number 1 says use the unit rate to figure out which is the better buy, and then we want to write down the unit price for our answer. It tells us to round to the nearest hundredth. That's the nearest cent and nearest penny. Okay. So on these, we need to check both of them. Okay, need to check both of them. Idea here, and it gives us a little bit of help, okay, because it's got it written in the order we want to divide. Okay, it's got price per battery, so we're going to divide by how many batteries we have. Okay. So let's see. This first one we'll divide by the price divided by 620. That's a lot of batteries. Let's see. So on that one comes out to, when we round to 2 decimal places, it's 34 cents per battery. Okay. On the other one, ooh, let me fix my pen here. 1 second. The other one we'll divide by 24. And if we do that one, that comes out to 36 cents per battery. Okay, so the blue one's the better buy, the top one. And we said it was 34 cents per battery. We need both things though. We don't need to just pick which one's the better buy. We need to have the unit price as well. Again, the main thing on those is making sure you have the right number on the bottom, right? The right number that you're dividing by. So whatever it says per, you want to divide by that number. On that one, we were dividing by the number of batteries. Okay. Questions on the one? Good with it? Okay. Number 2. Similar type of problem. We're not having to pick between 2. It says 2 liters of soda costs $2.90. How much soda do you get per dollar? Okay, so we're dividing by dollars here. Okay, so we're going to get 2 liters of soda per $2.90. 2 divided by 290. And again, it says round to the nearest hundredth or the nearest cent. So on that one, when we round, that comes out to 69 cents. Or no, it's not cents on that one, it's liters. 0.69 liters per dollar. Questions on that one? Okay, number 3, we got a ratio. It says if the ratio of children to adults is 5 to 8, and there are 150 children at the opening of a new museum, how many adults are in attendance? Okay. So on these, one really important thing is to make sure you're good on which number goes with which type of person here on this one. Right? So children is 5 and adults is 18. Okay. And then it tells us we have 150 children. How many adults are in attendance? There are several ways you can do these. You can think your way through it and not have to use an equation. But you can also, it's not too bad to set up a proportional equation. Right? So we could set up, we know we have 5 children to 8 adults. And we can set that equal to, got 150 children. And we want to know how many adults we have there. And when you solve the equation, you don't have to have the labels. I've just got them labeled to let you know where those numbers are coming from. So here we could do 5 times x would give us 5x. And then 150 times 8, remember we cross multiply. 1200. Divide both of those by 5. 240 adults. You could do the same thing without setting up the equation. You could say, well, now I've got 150 children, my ratio's got 5, so I could do 150 divided by 5, and then that'll tell you what to multiply 8 by to get the number of adults. The same idea. You get the same answer either way. Questions on that one? I just caught the beginning. I'm sorry, let me get a little closer. Oh, I divided by 5. Yeah, because we had 5x. And so to cancel that out, you divide both sides by 5. Yeah, sorry. Yeah. Sometimes I write it down and sometimes I get lazy. I got lazy on that one, sorry. Any questions on that one? Anybody else do it a different way you thought worked well? There's several, like I said, there's several ways you can think about that one. All right, so similar kind of situation on number 4. It says an election is over and a new city council member has been elected. The new councilman received 4 votes for every vote received by his opponent. The new councilman received 2,972 votes. How many votes did his opponent receive? So if you're okay on this one to look and say that the new person got 4 votes for every vote the other person got, so I need to divide by 4, that's okay. You can just divide by 4 and it's all right. But if you need to, you can set up a proportional equation like we did on the last one. Okay, so I'm going to call them new and old. Okay, so it tells us the new councilman got 4 votes for every 1 vote the old councilman got. Okay. Or opponent, I guess we'll call it opponent. It doesn't say we'll call it opponent. Okay. And we know the new councilman got 2,972 votes. We want to know how many the opponent got. Okay. So we're going to end up dividing by 4 either way. Right? If we cross multiply, we'll get 4x, 2972. Divide both sides by 4. And what do we get there? 743. Questions on that one? Okay. And again, if you can see you're out of way, you need to divide by 4, that's okay. You don't have to set up the proportional equation. Just giving you that tool in case you're stuck and don't see, do we need to multiply or do we need to divide? Then a proportional equation can help you figure that out. All right, number 5 is change the fraction to a percentage. So we have our fraction, we're going to divide first to change it to a decimal. So what I'm doing in my calculator is 10 divided by 105. So there I get 0.095238 something. And then either you can think about multiplying by 100, okay, or moving the decimal place 2 places to the right. Okay. And it says round our answer to the nearest hundredth. That means 2 places after the decimal. So here we would call that 9.52%. On that one? All right. Number 6. Some of these that look like this are a little trickier. This is one that's a little bit easier. It says what number is 20%, I cannot talk today, 26% of 750. So like we have a keyword per means divide, of means multiply. Okay, so here we can take 26%, change it to a decimal, and multiply that by 750 to find 26% of 750. We get 195. The ones that are a little trickier will give you some number, and I'll say like 35 is what percent of 750. Then it's a little more useful if you set up an equation. That's the type I'm going to give you. Okay, number 7. Got some sale price, or have a sale price to calculate here. Okay, let's see. It says a swimsuit that originally cost $140 before any discount is on sale for 20% off. If the swimsuit is then put on clearance for an additional 40% off the sale price, what is the final price? Okay. So we have 2 discounts that we're taking off. Okay. One thing you have to be careful of is that 20% off and then 40% off is not 60% off. Okay. And percentages don't add up, okay, that way. So let's do each one. Okay, we basically have 2 discounts to take. So we want to take off 20% of 140. Again, these are ones where you can, there's a couple different ways you can think about them. I'm just going to do it the traditional way that we're probably most used to seeing. So for our first discount, we need to figure out what 20% of 140 would be. So do 0.2 times 140. Gives me $28. Then I can subtract that from the original price. We'll get the price after the first discount. It's $112. And now we need to do our clearance price, so now it's 40% off. So You figure out what 40% of 112 is. So 0.4 times 112. $44.80, 44.8. So then I take 112 and subtract that number. Give me 67.2, or since it's money, that'll be $67.20. If we had a straight up 60% discount, if we take 60% off of our original price, we end up with $56. Okay, so doing multiple discounts, you can't just add up the percentages, because we're getting 20% off of 140 and then we're getting 40% off of 112. It's not off the same number. Questions on that one? Okay. All right, number 8. It's easier. It says your dinner bill was $55. If you leave a 20% tip, how much will the tip be? We just want 20% of $55. That's one we talked about. You may be able to estimate in your head. We'll get it exactly here. So 20%, 0.20 times $55. Gives us $11. And that one just asked how much the tip would be, not how much the total bill would be. So we're finished. Questions on that one? Okay. Number 9, we've got a sales tax problem. So similar to the discount, but we're not going to subtract when we get our percentage, we're going to add. So our item cost $129.99. Sales tax is 5.5%. So do be a little careful when we change 5.5% to a decimal. 0.055. Because when we move our decimal place once, it puts it in front of the 5, the first 5. And then when we move our decimal place again, we have to add a 0. 0.055. Okay, times our item cost. Okay. That gives me, rounding here, $7.15 tax. And then we add that to our original price. Get our total sale price. I knew I did something terribly wrong up here because I got like $1,000. I did times on accident instead of plus. So 137.14. Questions on any of those percentage or ratios? Nothing? Feel okay about them? Okay. All right, we'll get into a little geometry then. Page 10. Given the following figure of a tabletop, find the circumference. That tells us what formula we want, and circumference comes in two varieties. And we can either do pi times the diameter or 2 pi times the radius. This problem gives us the radius. So we'll do 2. Tells us to use 3.14 for pi. And then our radius is 30 centimeters. So yeah, 188.4 centimeters. And circumference and perimeter, they're just base units, right? They're not squared or cubed. Questions on circumference? And that one's not even hard figuring out which formula, because I mean it's just called circumference. So the formula will be labeled circumference of a circle. So. Okay. My word of caution here though, do make sure you're reading what you're finding, okay? And make sure you're seeing that you're finding circumference. Okay? And don't give me area on a problem like this. So take your time when you're reading the problem. Okay, this one says, given the following figure of a coaster, how many square centimeters of paint would be required to cover the top surface? So here we're looking for area. If we're trying to cover something up, or we could get area because it says square centimeters. We know we want area. So area of a circle is pi r squared. This one does give us the radius, so nothing fancy to do there. If it gave us the diameter, we would just have to divide by 2 to get the radius. Here we got 3.14 times 8 squared. So yeah, 200. It tells us to leave 2 decimal places in the hundredth, so 200.96 centimeters squared. So if you see square centimeters, or if you see we're covering it up or painting something or something like that, then that's area. Questions on that one? 12 is find the measures of the interior sum of the interior angles of a 36 gon. Our formula for sum of the interior angles is n minus 2 times 180 degrees. It says it's a 36 gons, I mean it's 36 sided. So do 34 times 180. Pretty big number there, let's see. 6,120 degrees. Problem like that shouldn't be too bad. There's not, we don't have a lot of formulas that look like that, so it'll say some of the interior angles. Okay. 13 says find the volume of the figure. So what kind of shape would we call that? Yeah, rectangular prism, rectangular solid. Okay. Yeah, that's good as long as you say it's rectangular, you're in pretty good shape. Okay. The main idea is it's not a cylinder, it's not a sphere, so it's rectangular. Okay. So volume for rectangular solid is length times width times height. I'm going to do capital letters. Okay. This one we just multiply all three of our dimensions together. 12 times 4 times 5. I get 240. Our units were meters, and since it's volume, we're going to have cubic meters, or meters cubed. Okay. 14. 14 says find the volume of the figure, so what do we call this one? What shape? Cylinder. Yep. Our textbook gets real specific with it and says it's a right circular cylinder, but as long as you can get cylinder out of that, you're in good shape. Okay, so we want the volume of a cylinder. Volume of a cylinder is pi r squared h. Here, the radius of the circle part is r. The flat side is h. And we're going to use 3.14 instead of pi, so 3.14 times 10 squared times 12. 3,768 meters cubed, cubic meters. Common mistake I see on these sometimes is make sure you're squaring r and not h. Sometimes I'll see people square the 12 instead of the 10. So. Questions on that one? Okay. 15 is find the surface area of the figure. If you really want to use this rectangular solid again, right? If you really want to use the formula, you can. Okay. You don't necessarily have to, as long as you know we're trying to add up the area of all 6 sides. But the formula is something like this. Okay, it'll be 2 times the length times the width plus 2 times the width times the height plus 2 times the length times the height. And maybe the formula in the book may be in a different order, but you get the same answer. Okay. So the idea is we're going to find the area of the front and the back. So we've got 2 of those. Okay. And the area of the left and the right, and the area of the top and the bottom, and add all those together. So it doesn't really matter what order you do the faces in. Okay, so I'm going to do 2 times 11 times 3. That's the top and the bottom. Then I'll do 2 times 3 times 4. That's the left and the right. And 2 times 11 times 4. Front and the back. And let's see what we get. Oops, sorry. I got 178 feet squared. Let me double check it. Anybody else get that? You did, okay. Well, I feel confident then. Okay, so 178 square feet. That's a lot of wrapping paper. That's about, that's a little bit too small probably to do most cars. If you were fitting a car in a box, I was thinking about if you bought me a car for Christmas, how much wrapping paper you'd need. I guess that's why people just put the big bows on there in the Christmas car commercials, right? All right, number 16. The 16 and 17 look similar, but they're different problems. Okay? 16 says you're building a house with a concrete foundation that needs to be 46 feet long, 30 feet wide, and 2 feet deep. How many cubic feet of concrete will be needed for the foundation? That's volume. We're assuming it's rectangular because of the way it gives us length, width, and height or depth. Okay. So we can just multiply our dimensions together. 46 times 30 times 2. Gives me 2,760. We're in feet. That's volume, so cubic feet. Okay. 17. A little bit different. You have to pay attention to what it gives you. Okay. So same thing. We got concrete foundation, but it says requires 2,000. Oh, same number. Oh, same dimensions and everything. Oh, that's what happens. You just let Hawk spit out random problems. Okay. Anyway, we'll talk about how to work it. Okay. You may be able to guess it. It requires 2,760 cubic feet of concrete. If the foundation is going to be 46 feet long, 30 feet wide, how deep does it need to be? Well, the last one we can tell. Okay, but the way we work this problem, okay, we're still using volume is length times width times height. But one of the numbers it gives us this time is volume. So we'll plug in for V, and then it gives us length and width. And we're looking for height or depth. Okay. And so the way we would work this, if we didn't already have the numbers on the last one, right, we would do 46 times 30. Okay. Gives me 1,380. Yep. Yep. Okay. And then we would divide both sides by 1,380. Yeah, that's right. Page will be 2, should be. Yeah. For depth, if you want to call it D, you can, that's fine. You can call it whatever you want to. Okay. Got the idea on that one? Yeah. Okay. 18, getting into some probability here. 18 says Neil has 191 songs on a playlist. He's categorized them in the following manner: 32 folk, 21 gospel, 17 Latin American, 10 hip hop, 25 rock, 38 rap, 48 country. He begins listening to his playlist on shuffle. What's the probability that the first song played is a country song? So how many country songs do we have on the playlist? Yeah, 48. out of how many total songs? 191. Yeah, luckily we don't have to add it up. Okay, it tells us at the beginning he's got 191 songs. So okay. We get 48 out of 191 there. It says put it in lowest terms. I'm not going to be picky about that if it's one like this. Well, that is lowest terms anyway. 191's prime, so you give me that. Or it says the decimal rounded to the nearest millionth, so was that 6 decimal places? A fraction is probably easier, but you know, it'll be 251,309 on this one. Either one of those is okay. Fraction's probably less hassle. This particular problem. Okay. We're still knowing. 19. So we got an experiment where we're rolling a 6-sided die and then we're flipping a coin. Possible outcomes for the 6-sided die are 1 through 6. And then we either get heads or tails for the coin. Identify the sample space. So we want to list out all the possible outcomes. So here we want to write it like a set. I'm going to put it in curly brackets and put a comma between each one. So just be kind of systematic about how you list them out. I'm going to do all the numbers with heads first, right? So we could get roll a 1 and get heads, or a 2 and get heads, or 3 and heads, 4 and heads, 5 and heads, or 6 and heads. Or we could get tails on the coin. Right? So then we would roll 1 with tails, 2 with the tails, 3 with the tails, 4 with tails, 5 with tails, or 6 with tails. Kind of ran out of room there, sorry. That's all of them. Hopefully now you should be able to figure out how many possibilities you're going to have. Now we've got 6 choices for the die, 2 choices for the coins. 6 times 2 would be 12. And we do have 12 up there. And it doesn't have to be exactly like that, right? If you did tails first, or if you did the, it's even okay if you do the coin, so like if you had H1 instead of 1H. Okay. As long as you got them all in there, I'm happy. Question on that one? Okay. 20 says evaluate the factorial expression. Okay, so remember factorial means we start with whatever number's in front of the exclamation point, and we're multiplying, stepping down one number all the way until we get to 1, right? So 11 factorial is 11 times 10 times 9 times 8 times 7 times all the way down to 1. So the first thing I see we can simplify on this one is our subtraction. 4 minus 2 factorial, that will be 2 factorial. And then hopefully you kind of remember our little cancellation trick that happens right on the top. I'll go ahead and write the whole thing out. You don't have to write it all out. And that's what we got on the top. On the bottom, we got 8 times 7 times 6, all the way down to 1. And then for 2 factorial, we got 2 times 1. Again, you don't have to list every single term out if you remember how it plays out. So what I'm thinking here, we want to cancel out as much as we can. So I've got 8 on top and bottom, 7, 6, 5, 4, 3, 2, 1. So we end up with 11 times 10 times 9 on the top. 2 times 1 on the bottom. We can figure out what that is. That's 990 on the top, divided by 2. So 495 is our final answer there. Again, you don't have to write that much down. Just wanted to try to make it clear what was going on. If I'm doing it myself and not trying to show somebody how to do it, I'm going to see that on the 11, everything 8 or smaller is going to cancel out. So I'm just going to go straight to that and then that. Questions on that one? Those are not difficult, but they can be confusing if you don't understand what's going on. So if you have questions, let me know. Okay. One more. You can think about this in a couple of different ways. This one says the mother duck lines her 11 ducklings up behind her. How many ways can the ducklings line up? So you could just do this one with the fundamental counting principle. Right? You could say when she chooses her first duckling, she has 11 choices for who she puts in front. But then she's already picked a duck, right? So for the second spot, she only has 10 choices. And then for the third spot, she has 9 choices. Right? And it would work out that way all the way down. Every time she picks one, she has 1 fewer choices for the next one. So she only has 1 choice for who to put last. And you do it that way, and then you may recognize that's 11 factorial. Or, so that's fine. Or you can realize that we're doing permutations. We have 11 ducklings and we're choosing 11. Okay. So you could do this, and our formula for that is 11 factorial over 11 minus 11 factorial, which is 11 factorial over 0 factorial, which is, remember 0 factorial is 1. So either way, 11 factorial, and that number is probably too big for most calculators. So 11 factorial is fine. Oh no, mine works. Let's see. Mine will handle that. Okay, so I got 399, 168, 00. So what is it? Yeah, that's not too bad. 39,916,800. 916,800. So if you put 11 factorial, I'm okay too. Okay. Questions? Okay, well, that's it. If you didn't get on the sign-in sheet, make sure you get on there before you leave. Okay, and I'll see you in here on Wednesday.